Today's talk will be about continuous deployment using Jenkins, Docker, and a few other things. It will be mostly hands-on, so I will go through very few slides and then try to demonstrate a few of the things I will be speaking about. It's terrible. I don't see anything from those reflectors. It's like in Auschwitz. My name is Victor Farcic. I work for CloudBees. We're a company behind Jenkins, open source enterprise. I'm also one of the Docker captains, so I'm really present in both of the projects and very much involved. Wrote a couple of books, which you should buy immediately. That's the most important thing of this talk. In case you want to see the presentation later, that's the address. I will post it probably. I will give it to organizers, give the organizers later. So, and this talk will be very fast. I'll be speaking very fast. I'll be doing things very fast because I need to do approximately 2 hours workshop in 45 minutes. So that's what you're getting now. Today everybody's talking about Docker, everybody's talking about continuous deployment, and everybody is hopefully using Jenkins. If you're not, that's okay. You can apply the same practices anywhere else. And those three concepts, tools, really fit well together because Docker allowed us to do things that we couldn't do before, at least not with the speed that we are doing it. And continuous deployment, everybody wants to do continuous deployment. Most of us cannot do it, but that's a separate issue. So who's using Docker here? OK, that's a fair number. It's much more than last year. In production. If it's not in production, just lower your... Excellent. Brilliant. Brilliant. So I'm not going to go deep into what Docker is because everybody knows, unless you're living under some rock, you know what Docker is. It has different components, and they form certain ecosystem that we are leveraging to our benefits. Today I will be using mostly Docker Compose, a bit of Docker Compose and mostly Docker Swarm. Same thing applies everywhere else. I'll be using those tools that you see there. If you want to repeat at your home, just download those tools, install them. If you're unfortunate to use Windows, then you will need git bash. Anyways, I will start doing stuff immediately because if I want to do continuous deployment, first thing I need servers, right? I cannot continuously deploy to nothing, right? So I'm going to start by creating servers immediately. And I'm going to get, do you see this screen? Is it too small? You see it? Excellent. I'm going to start running it first, and then I'm going to explain what's going on. So what I'm doing right now is that I'm using Terraform to create my server. So I'm going to start with one node, and later on I'm going to create a cluster with 3 nodes, just to demonstrate how clusters work. Before I did this, I created, please. And this is like theatrical pose. It will hopefully work. If it doesn't, I don't have a talk. Nothing to do with you guys. OK. What the heck? OK. It will happen, I hope. Anyway, so what I did before I came here, just to save us a bit of time, I created AMI images, Amazon Machine images. And the reason why I use images because we tend to use immutable infrastructure these days. So that means that if you're using Ansible, Chef, Puppet, please stop doing that. Those tools are becoming obsolete. What we want is really to create images that have everything that the server needs. And finally, and from those images, we create as many servers as we want. That's immutable infrastructure, meaning it's unchangeable. Nobody can SSH into servers. I will be SSHing today, but more to demonstrate certain things. So I'm creating the first server, and once that is done, I will create 2 more, and then we can see how continuous deployment works on a cluster. In cluster, in my sense, in my case, means that if you have servers, that does not mean that you have clusters. If you give servers your names, that does not mean that you have a cluster. Cluster means that you have a single entity that has a lot of CPU, a lot of memory, and you deploy to a cluster always, never to servers. Simply because if you deploy to servers, that's not fault tolerant, that does not scale well, and so on and so forth. So my server is about to be finished, and I'm going to create 2 more immediately after that. Who's familiar with Terraform? OK, that's a smaller number. Shame on the rest. Really. Who's using Chef, Ansible, Puppet? Stop. They were cool. They served us well. I'm really fond of Ansible, but they're tools designed to leverage static infrastructure. They're designed to work with bare metal servers. They really don't know how to handle cloud. And today everything is a cloud. Even if you run your own servers on-prem, still it's cloud. So my server is finished. I'm going to refresh the state from Terraform to see what it did. And it should give me the IP. There's the IP of one of the servers that it created. I'm going to get a token so that I can join my other nodes to the cluster. In this case, it's going to be Swarm cluster, but same would apply to Terraform. And if you're unfortunate enough to use Mesos, it applies to it as well. So I'm creating the other two servers, and they will join the cluster. And after a minute or two, I can start doing some nicer things. How much does it take in your company to get a cluster? If you call them now, when do you get it? Next week? Next month? Do you open Jira tickets to get your servers? And those Jira tickets are sent to a graveyard when they die, slow death. Yeah, it's really hard to understand how we lived in the past and how some of you are still living in the past. Anyway, my cluster is almost done. And I can finally enter it and show you how it works. OK, so I'm going to go into my cluster, SSH into it, and execute command docker node ls. You see it there, and this is how Docker sees my cluster. Docker already did its work, and it sees that there are three nodes in a cluster, and I can finally start deploying some services. And after those services are deployed, I can show you how continuous deployment works. So I'm going to enter into one of those servers, SSH into it. Excellent, I'm there, and I'm going to create the first service, and I'm going to show you quickly how it works. This is a Docker service, uses Docker Swarm. It says Docker service create. I'm giving it some name. I'm going to publish port 9090 that maps to internal port of the application that is on 8080. So it means that this service will be accessible on this port. I want it to run on any of the managers, exposing Docker socket. I'm not going to go deep into it now. And finally, the name of the image, Docker image, is Marks Visualizer. That's basically all it takes to deploy to a cluster. Pay attention that I'm never going to deploy to never going to tell Swarm where to deploy it. I'm going to always tell you just to do something. I'm going to specify my requirements, and this doesn't work. Still doesn't work. It will work. What the heck? Today is not a good day. OK, it is running. OK, here's my first service that I deployed, and this service has no real purpose. The only reason why I'm deploying this service is to show you how my cluster looks like. This is my cluster. It has 3 nodes, and one of them is hosting a service. I did not tell Swarm where to host that service. Swarm decided for myself, depending on available CPU, available memory, and all those things. Pay attention that it does not matter whether I'm hitting this node or that node or that node. From whichever node I enter and send a request to that service, internal software-defined networking will forward that request to the service and do load balancing. I could easily access the server from any other server, and it would still work. So OK, that was kind of easy. Let me show you how networking works. I'm going to enter into one of the servers again. OK, I'm already in a server. I'm going to create a network. I'm going to call that network Proxy, and I'm going to show you that that network is really there by executing ls. And you see that I created software-defined network. It's called over there Proxy. It's overlay. It applies to the whole cluster. And ingress network, which comes by default, that forwards all my port request to the destination service. I'm going to show you how networks looks like in a few minutes. But before that, I need a service, a real service this time. to deploy, because what I did before was really horrible. So because I had to remember too many arguments. So this is my definition of a service, of a stack, actually. And it says, OK, this is the service I'm going to do pass through continuous deployment very soon. So it says there are two services. One is called main. The other one is called DB over there. Main defines an image. It defines environment variable that says the database can be located on something called DB. Now, one of the important things about this service and how your services should look like is that there is no configuration file, there is no property file. Those things are dead. They're dead simply because you cannot specify an IP of a database because you don't know where the database is. And even if you do know where the database is, tomorrow it will fail and it will be somewhere else. So instead of hard coding IPs and all those things into configuration files, those things that you probably most likely do today, we use service discovery. So I'm going to tell this service, which requires a database, that there is an environment variable and it should discover the database by the name DB that happens to be the same as the name of the service over here. Belongs to the two networks. You will see that later why. And I want immediately to run 3 replicas of this service. And in case somebody makes a new release, I want to update 1 replica at a time with delay on 10 seconds. That will give me rolling updates. That will mean that I can deploy as often as I want because there will never be downtime. Because in worst case scenario, if I stick with 3 replicas, there will always be 2 replicas up and running while 1 is being updated at some given moment. And finally, some labels. Those labels I will use for my proxy because everybody has a proxy, everybody needs a proxy. But unlike other people, I don't believe that we should have separate configurations for different parts of the system. So I'm giving my service label that says, if you want to configure yourself through a proxy, this is your path /demo, and this is the internal port you should be fetching things from. And I assume that proxy is dynamic. Everything is dynamic these days, and proxy will find out that information from the service, and it will configure itself automatically, right? The idea is that whenever we deploy a service, that should be the only action we do, and the rest of the system should always adapt to what we're doing, right? Instead of us going and changing some configuration files and doing all those things that we were doing in the past and we shouldn't. Now, another important thing is that this service belongs to the network default, and this service database is also in the same network. What that means is that when 2 services are in the same network, they can speak with each other no matter where they are inside of a cluster. And all they need to know is the name of the service. So this one can speak with database just by knowing the database is called DB. Networking will do the rest, right? No configuration. So let me deploy that and show you how it looks like. So I'm going to say docker stack deploy, the name of the file that I just showed you, and I'm going to call the stack go demo. And I immediately got acknowledgement saying, OK, I understood your command. It will happen sometimes in the future. We don't know when, but it will happen soon, hopefully. So let's see whether that soon is actually already done. I'm actually going to show you the process is running. Something terribly wrong with the network. OK. And you see actually that already I have 3 replicas up and running, and 1 replica of the database somewhere as well. Now, 2 of those, 1, 2, 3 of those failed. The reason why those failed is because 3 replicas of my service were up and running, tried to connect to the database and failed. The design is made in such a way that it fails immediately. The whole process stops. And the reason why it failed to connect to the database because the database was not running at that moment. And then it tried again, Swarm detected a failure and restarted the process. And finally, at that time, the database was up and running, and this is all peachy, right? And if you want to see it visually, this is how my cluster looks like, right? Swarm is distributing my services across the cluster, and you can see that 1, 2, 3 replicas of my backend API is up and running. There is a database also somewhere in the cluster, and they can all speak with each other without any configuration, just with service discovery and software-defined networking. OK, so now the last thing, one more thing that I need to make accessible this service through the proxy. I did not expose any port. At the moment, this API is completely inaccessible to anybody, right? Except those that live in the same network. So I'm going to download the proxy, and I'm going to run it immediately. And if you remember those labels from before, proxies are today intelligent enough that they can actually read those labels and auto-configure themselves using those labels and generate their configuration that is constantly up to date. And if I did it right, My proxy should be up and running. It is already up and running. I have 2 instances of the proxy and 1 of the swarm listener that listens to events and reconfigures the proxy. If this all worked, if I managed to do all this without any actually configuration, I should be able to send a request to my API and say demo hello, and actually there it is. It's all whole cluster is up and running, configured, and operational without me changing really anything except deploying services. So let's see what else. And you can see also in the cluster, proxy is also somewhere there. Everything is distributed across the cluster to the best of the knowledge of Swarm. So now the last thing I need before I actually jump into Jenkins, because this is actually the subject of this talk, I'm going to go back there and I need a persistent storage, because everything I did by now is either stateful or the database does not need to persist storage simply because they use replication between themselves. If your database doesn't use replication, then just kill yourself or change the database. One of those 2 things, please. So I'm gonna show you how stateful services should be handled in case you do have one. And I'm gonna show you that by the another service, another stack. This is registry. This is where we store images, and it's stateful, so I need to persist its state in case of a failure. So I'm going to do the same thing as before. This is the image registry. I'm going to open a port 5000. I'm going to tell Swarm, unlike previous services, that I want 100 megabytes of memory reserved for this service. But the really important part why I'm showing you all this is this thing here. It says, I want you to map this directory inside of container, which is where state is stored in case of this service. I want you to map to something called registry. And registry over here says use driver Rexray. And I'm going to show you what it does very soon, because Rexray is really cool, and it allows me to do things again without any additional things. So I'm going to create a volume. Well, creating a volume means that you're creating a storage for something in Docker world, and since I'm saying that I want to use Rexray, it will use the configuration that I did in beforehand. And just imagine this configuration says use AWS, use EFS, Elastic File System. It can be anything else. And Rexray should handle everything for myself. And I can show you this by creating this service, saying Docker stack deploy one more time. I want to deploy registry, and I'm going to go to my AWS account and show you what happens. Don't use UIs; they're evil. But I'm going to do it now. Fuck. Okay, things fail when you don't expect them to fail. What? This is not happening really. Okay, you need to trust me. I'm going to skip this part. You need to trust me that what Rexray did is that it created a EFS drive in my AWS account and attached the drive to my service, so that the service can persist its state over and over again. So in case of a failure, state will never be lost because it's somewhere separate on a network drive. Everybody knows what EFS is, right? Okay, excellent. And let's see whether my registry is really running. It's starting. It takes longer than other services because it takes a bit of time until that drive is created. Let me see if I got SMS from Amazon. Yes, I got it. Console, login. Okay. Okay, they sent me another one. Excellent. This is paranoia to the fullest. 539. Yes, it's my account. Please do it. Okay, if I go to EFS, you will see now that this one was created out of the box, was created automatically, right? Docker handles everything through Rexray. And somewhere there, it's still creating. AWS is slow and expensive. If you want something fast and cheap, then go to DigitalOcean. No, seriously, it's better and cheaper. But anyway, everybody knows EFS. Everybody knows Amazon. So let's see whether this is done. Okay, so my registry is up and running. It persists its state across the cluster, across failures, and I can move on. I can pull an image from Docker Hub just to demonstrate how registry works. I'm going to tag it so that I put the address localhost. This is the address of my where the registry is. I don't know whether the registry is on the same server where I am right now, but since Docker networking will do the trick, I can say localhost and it will be forwarded wherever that is, and I can push to the registry and see that it works. It works, and you need to trust me that in case of a failure, it will be preserved because it's everything on a network drive. So I'm almost finished with what I need for now, so I'm going to move. Now you know everything you need to know about Docker, right? You learned everything you need to know. You know that there is a cluster. You know that you can deploy services. You know that you can persist state, right? So that this was very short introduction, so that you have a better understanding what I'm going to do with Jenkins, because that's the subject of this talk. So continuous deployment. Everybody knows what continuous deployment is, right? At least nobody's practicing, but you know what it is. Half of you is probably saying that we are practicing, but you're faking it, right? It's very simple to explain. Every commit goes to production. If it doesn't, you're not doing continuous deployment. So the process is very simple. You check out some code. It's always the same. Check out some code, run some static tests against static code, build something, run functional tests, push to some registry to preserve its state, to preserve artifacts, deploy to something that is almost the same as production. Maybe not. The only difference would be capacity, run some tests, deploy to production, run some tests. And all that is fully automated, and it goes on every single commit. And don't make branches, please, because if you use branches, then you're not doing continuous deployment unless those branches live for only a day. Because I've seen companies say, we're doing continuous deployment. We have a branch that we don't deploy anywhere until we merge to master 3 months later, and it's continuous. Just silly, right? So I have additional requirements. I want to have freedom to code in any language I want, simply because I think that we are all moving toward microservices. We are all giving freedom to our developers to choose the best language for the task. If it's Java, great. If it's Go, even better. Whatever you want to do depends really on what are your requirements, and I want to have the freedom, and that's what Docker gives me, among others. I don't want to depend on any specific framework. I want to choose what I work with. I don't want to depend on infrastructure, meaning that I don't want to open Jira tickets. I want to have infrastructure as a service ready for me whenever I need it. That's what Swarm gives me, or Kubernetes, or Mesos. I want to have immutable deployments. That's very important, because if you update your release in production by changing something, then it's not immutable, it's mutable. That means that you have something that you tested in production is not the same as tested in staging environment is not the same as in production. Then QA opens the Jira ticket and you say it works on my laptop. Minimum time between steps, because I really don't want to waste time on things. You see how fast I speak. I really get impatient, and I want everything to be automated. Everything needs to be automated because it's silly for me to spend my time doing the same thing that I did yesterday. Machines do those things better. I want to do creative stuff. I want to do something interesting. And the reason why I have all those extra requirements, because I'm very impatient. I don't like waiting for other people. And I'm especially not waiting for other departments. Departments are evil. I hate handovers. I hate those when companies are structured and say, okay, you do your development and then you throw it to QA, and then QA throws to somebody else. I like working in teams that are self-sufficient, that can do everything from requirements to production and monitoring as a single team. And when I say a single team, I mean 6 to 8 people. Anything bigger than that is not a team. That's a school reunion or a football match. It's definitely not a development team. I dislike depending on others. I'm a nerd, I'm a social. Most of you are a social, that's why you're in computers and not something more interesting. And it's nice when you're a social not to depend on others. I really hate doing things over and over again. That's boring, and so on and so forth. So the tool I'm gonna be using today is Jenkins. The reason is very obvious, because I work for CloudBees. We are a company behind Jenkins. If you like something else, that's okay. Everybody's familiar, you know what Jenkins is, right? Okay, as long as it's not you deploy, you're fine. It can be something else. Jenkins is very short introduction, because most of you know what Jenkins is. Jenkins is a tool for continuous integration, continuous delivery, continuous deployment. It is orchestrator of everything that is happening within your organization. It's really, really awesome. Now you know everything you need to about Jenkins. You learned 2 things by now. Everything you need to know about Docker and everything you need to know about Jenkins. So I'm going to run Jenkins inside of a cluster. And I'm going to do the same thing as I did before. I'm going to enter into one of my servers. And I'm going to download the stack YAML file that defines my Jenkins. I'm going to show you that file. It's very simple. It says, okay, I want to run something called V.Farcic Jenkins. I usually extend official images to provide additional features that I need for a given moment, but it's very, very similar to official Jenkins, just that this one works better because it's automated. I'm going to open a port 50,000. That's not a port for UI. UI is going to go through the proxy. This is the port only for agents, and so on and so forth. It belongs to the same network proxy, so that proxy can reconfigure itself, and there are labels that define, give information to the proxy how it should configure itself. And the new thing here is that it uses secrets, right? I wanna specify username and password for my Jenkins instance, and I don't wanna do it in a insecure way. So I'm specifying Jenkins user and Jenkins password and secrets, and you're gonna see what that means. And I just realized that the first letter of everything I do is eaten by the projector, so you need to imagine it. Anyways, so I'm gonna create those two secrets, which are gonna be very secretive. I'm gonna say Jenkins user is going to be admin, and Jenkins password is going to be admin as well. And I'm going to deploy that stack. And Jenkins is relatively big. I mean, by big, I mean a couple of 100 megabytes, so it will take 30 seconds. It's preparing. And also, you will notice that since Jenkins is a stateful application, just like registry, I also used volumes. I said I want to use something called main, and main should be defined here, and it says use rexray. So I'm going to persist Jenkins also on a network drive. I don't want to speak with my colleagues right now. So if you go back to my Elasticsearch, you will see that another drive was just created is being created for me. You see that AWS is creating a drive so that I can persist the state, and everything needs to be fault tolerant, right? So it's going to happen very soon, hopefully. Let's see whether it's still running. Still preparing. That's because why? Yeah, because AWS needs a minute approximately to create a drive. It will be running very soon. Theatrical pause. You can ask questions. You have 30 seconds for a question. No questions? Okay, you can watch me in silence, that's okay. I'm not pretty, but if that's what you like. Let's see whether my drive is ready. It tells you how impatient I am. I get really pissed when things last more than 10 seconds. It's still creating the drive for me. And while that is happening, you can see that Swarm continues distributing services across my cluster to the best of its abilities. And you just need to, I don't have time to show you failover, but you need to trust me that if I would kill one of those nodes, I would have no downtime, except in case of Jenkins, because I cannot scale Jenkins, but everything else would be completely transparent. If node is killed, Swarm would reschedule those replicas somewhere else. And hopefully I would have a system that would actually recreate that node, and I would have even additional node with services running in maybe 30 seconds or something like that. Let's see whether this is done. Still creating. Don't use AWS, it's slow. Oh no, it's actually running. Okay, so my Jenkins is running. I can continue. I'm gonna see this is my presentation, excellent. So I'm going to go out, and if everything is correct, if Jenkins is up and running, if everything was automated to add my username and password, and if plugins are installed automatically, and if proxy is configured automatically, this should work. I should be able to just run it, and it doesn't. But that's because the process, even though the service, the container is up and running, the process inside that the container might not be up and running yet. Jenkins itself process after the container is created takes maybe 30 seconds. I can confirm that by seeing the logs. No, logs. It is running, it should be okay. Yeah, it is running. It is starting 15 minutes. Excellent. So while that is running, since I don't have much time, I'm going to proceed. Imagine that this is running. If I'm going to run continuous deployment, I need a separate cluster for my builds. So I'm going to create one more cluster. I'm going to use the same process with Terraform that will create one additional node. I need always to create the first node separately so that it can initiate the cluster and other two nodes that will join the cluster. And I need a separate cluster simply because I don't want to build and test in the same production cluster where my production services are running. I don't want to mix those two things. So once this is done, I'm creating a second cluster. Let's see. It will take a few more seconds while we are waiting for Jenkins to work. Everything is slow today. Okay, it's connected. Now it will install Rexray. Okay, I can refresh the configuration. That's fixing a bug. You know, recent releases of Terraform. It will take a second. Okay, I'm gonna get security tokens so that I can join additional servers to the cluster. I'm gonna get IP of the newly created server so that I know where those nodes should join, and I'm gonna create additional 2 nodes so I have a second cluster with 3 nodes that will be all pitchy, and I can go back to Jenkins. Why the heck is not working? Everything is slow. Come on, you have 12 minutes. I'm only halfway through. Okay. Yeah, there's my Jenkins. And if you remember the username and password that I specified at the beginning is admin. That's very secretive. And it's up and running. And I don't need the visualizer. You see that it's very colorful. We don't need this anymore. So I'm ready to create a new job. I'm going to create a job while I'm creating. No, first I'm going to create agents. Excellent. So this is done as well. So I'm going to create this first, and then I'm going to explain what is happening. I'm going to enter into the newly created cluster. I'm gonna get IP of one of the production servers, which is this one here. And I'm gonna download another stack that defines my Jenkins agents. Jenkins agents are basically workers that do stuff for you. And I'm gonna create it immediately. Again, I need username and password. I'm gonna use a secret, and I'm gonna deploy a stack. Now this stack is a bit special because it defines that the service, everything is the same as before. The only new thing is that it defines the service being global. What that really means is that the replica will run on every single node of the cluster, which is what I want with agents. I want them to run everywhere in a second cluster. And that is going to happen relatively soon, and I can move on and confirm that my agents are created indeed. I will do that by going to Manage Jenkins. Manage nodes, and you see actually that my agents are already, my second cluster is already being added to my Jenkins master. It will take maybe a couple of seconds to initialize, but that will be done very soon. So I have a second cluster completely connected to Jenkins, and I can do whatever I need, build, test, deploy, and all those things. Deploy actually to the production, but we'll get there. So the last piece of the puzzle before I create actually the real continuous deployment pipeline, I'm gonna go out of here. I'm gonna go to the newly created cluster and create the same registry so that I can store Docker images, and so that I can push them there and pull from the production cluster, and that is being deployed. Excellent. You need to trust me on that one. And the last thing I'm gonna create is I'm gonna go to Jenkins and create an environment variable that tells me where my that will define where my production cluster is, so that I know where to deploy. Where is this? Configure system. I will need IP of my server. That is this. Okay, this is where my production is. So slow. Okay, so I got environment variables. I'm gonna say prod IP. I want you to deploy your stuff here. Okay, excellent. So I'm now ready to create my continuous deployment pipeline. I'm gonna copy and paste this job, and then while it's running, I'm gonna explain you what's going on. I'm gonna say go demo. That's how I'm gonna call my job. I'm gonna choose pipeline. If you're using Jenkins and not using pipeline, just stop doing that. Freestyle jobs are dead, believe me. So I'm gonna go to the pipeline, and I'm gonna paste this job. That was horrible. It's not what I wanted. And I'm gonna explain you what this job does. Yeah. Here it is, saved. I'm gonna run it, and I'm gonna show you. Jenkins is but ugly, but if you install Blue Ocean UI, it makes it prettier. It doesn't hurt our eyes anymore. So what my continuous deployment job looks like is this, right? Everything is Dockerized, everything is using a pipeline in Jenkins. It says, I want you to run unit tests as a container. I don't care what is the language behind those unit tests. I don't care about frameworks. Team behind this project decided that actually we're going to call it unit, and there will be some unit tests there, and you will see it soon. If unit tests are passed, I'm going to build an image called Go Demo. Then I'm going to run staging dependencies. What that means is that I'm going to run that application somewhere in a production-like cluster. I'm going to run all the dependencies. If it needs a database, it will run database. If it needs proxy, it will run proxy, whatever it needs. And once I'm finished with running all those dependencies, I'm going to run functional tests, staging tests that are going to validate the live application, whether it's correct. If it is, I'm going to store a Docker image in my registry so that I can pull it from another cluster. And finally, I'm going to go to production and say Docker service update. I want you to update the existing service with the new image that I just built a moment ago. And that image is going to be 2.something build number. And finally, I'm going to run some production tests. And once all that is done, no matter the outcome, I'm going to destroy all the services that I'm running in staging environment, simply because it's a waste of resources to have application up and running longer than absolutely needed. And you can see that pipeline is running. It's running unit tests and so on and so forth, and soon it will finish. And I will have my application updated in production. It will run release 2.1. 2 because I say so, and 1 because this is the first build of my pipeline. And that's pretty much how much time do I have. 5 minutes. That's 5 minutes for questions, while you're watching continuous deployment pipeline being executed and on every commit. No questions. Habla español.
Questions in Spanish?
You can ask in Spanish. You can ask in Catalan.
Also?
You can ask in any language you want. That does not mean that I will answer. Was this too fast for Barcelona? Seriously. Okay, the first one who asks the question gets Jenkins for free. And Docker for free. And Gmail. No, still nothing? No. You're a very unmotivated crowd. It's running staging tests. That means that it's creating a Mongo database, which is one of the dependencies. It is deploying the service that was built. And you can see here that functional tests are finished executing. Actually, it's already is deploying now to production. And it will be done in a minute. Nothing? Okay. I can actually prove you that it's running in production by going to the server and showing you the release. And you will see that the previous versions were killed, and there is one instance of 2.1, 2 instances, only 2, because rolling update is still up and running. It takes, I set it up to 10 seconds, and 10 seconds later, the third replica will be replaced, and now you see that there are 3 replicas with release 1.2.1, and you need to trust me that there was no downtime, that no users were affected, maybe a bit of a performance implication, nothing else. Anybody question? Yes, please. Huh? So if you create, if you say Docker secret create, that secret is distributed across all the managers of the cluster, and they are in encrypted form and all those security stuff. So reasonably hard to hack it. And then when you create a service that uses that secret, like I did, what happens is that Docker creates an in-memory file system inside of all the containers that form that service in memory, so that if container stops, there is no trace on a file system of that secret. And those secrets are stored in a directory, run secrets, and the name of the secret. They're files. Now, what you do with those files, normally most applications, you would need to have a script to transform that file into whatever your application expects.
Can you integrate SonarQube with pipeline?
Can I integrate what?
SonarQube analysis software.
If I absolutely have to, yes.
Yeah.
Yes, you can. I don't see a big reason for having SonarQube, but if you have to, yes, you can do it.
Thanks.
Because I think that SonarQube is great, but I think that SonarQube fosters in many companies very bad practices. And that's kind of like, okay, we have a stats about failing tests. Who needs statistics about failing tests? That's silly. Failing tests should be fixed. They should not be looked through some stats and stuff like that, right? But yes, if you want to integrate it, then you would plug it into Jenkins and just send results to SonarQube. That's easy.
Hi. As you know, most of any Jenkins installations rely a lot on plugins. How could you initialize Jenkins?
I hate plugins.
Yeah, well, most of us use them.
Yeah, I think it's wrong. I really think it's wrong. And that comes with the guy who lives from those plugins. The reason why I think it's wrong is that there are cool plugins. Like Git plugin is great. Like I use Git there, I think it's great. But then there are plugins like Ansible plugin, right? That you need to fill in 20 fields instead of just saying SH, Ansible playbook. That's it. I prefer SH because I think that essentially you should not start using Jenkins as a tool for coding your pipeline. Your automation should be already done out before you come to Jenkins. It should be your scripts that you can run from your laptop that you can afterwards plug into Jenkins. So I really advise against plugins like Ansible and Docker plugin. They're just silly.
Well, I might agree with you. There are sometimes like business requirements, like we rely on that plugin to show some information or stuff like that.
Yeah.
So for example, some build dashboards that you put on TV or something like that. So sometimes we need to put that. Can you initialize like going through scripting like install?
Yeah, you can. Most of the plugins, I mean, most used plugins are available through pipeline. So you can. There is a syntax for every plugin how to use it for pipeline. Not all, but most. Visualization is a good example. I mean, that's a good example of something that you cannot easily script, and there is no reason to run it on a laptop. So yes, my blog. If you want to follow it, tweet. If you want to tweet it, books. You must buy them immediately, and that's about it. Thank you for your time. Unless you change your mind, you have a question.